Welcome everyone. This is section 4.3 in the book that we never use, Trigonometric Functions of Acute Angles. Alrighty, here are your 6 trigonometric ratios. Just a quick review here. Here's my angle theta, there's my angle theta. Sine is opposite, that's what we mean by opposite. You go straight out from the angle, there's your opposite side. Hypotenuse is also easy if you think of the hypotenuse as being the side opposite the right angle. Adjacent is just kind of whatever's left. It gets a bum route. Sine, S-I-N-E, cosine, C-O-S-I-N-E, and then tangent, T-A-N-G-E-N-T. Please don't call these sin and cos. They are sine and cosine. Last thing I wanted to point out is notice how I have my reciprocal functions kind of on top of each other. Secant is just the reciprocal of cosine. Flip the fraction. Here's just a little funny I stuck in. You're welcome to read over it. Find the 6 trig ratios for angle C and angle A. Okay, so the idea here is that you have to go through all of your ratios. We'll start from angle A. Why not? It's the one at the top here. So we have all 6 of them. We'll have sine of A, cosine of A, tangent of A, whoops, cosecant of A, secant of A, and cotangent of A. Alright, so what are these ratios again? Sine is opposite over hypotenuse. So the opposite of A is 5, and then the hypotenuse here is 13. And you would just keep repeating this process. So cosine, the adjacent. Uh-oh, we have a problem. Where's the fifth side? Oh gosh, where's the third side? We have 5, we have 13. How do I get the last side? Well, you notice it is a right triangle, and so you need to use the Pythagorean theorem. We have 5 squared plus, let's see, what side are we missing here? C squared technically, but equals 13 squared. 25 plus b squared equals 169. B squared equals 144. Does not look like a 4, and so b equals 12. And of course you may have even known that this was a 5, 12, 13 at this point. 12 over 13. Tangent is opposite over adjacent, which is 5 over 12. Oops. 5 over 12, etc. I'm going to pause the video so I can write them all out. Just check your work. Ooh, one more quick thing. You know, since you already found sine, the cosecant is just the reciprocal. So instead of sitting there trying to say, oh gosh, cosecant, what is that? That's hypotenuse over opposite. You've already done the math. Just flip the fraction. So again, I'm going to pause this, write out the rest of them, and then you can come back and check your work. Okay, here are all of the ratios for angle A. And then again, I'm going to pause it and write up all of the ratios for angle C. Alrighty, here are all of the ratios from angle C. Hopefully you didn't have any issues coming up with these. Here's our first special right triangle. You're being asked to find the sine, cosine, and tangent of these acute angles. So you're like, okay, no problem. I got my 2 angles labeled. I know the third is 90. It all adds up to 180. It's looking good. But how do I find the sine of B if I don't have any sides? I mean, nothing is labeled here. How can I do this? You notice that these 2 angles here are the same measure. They're congruent. Isosceles triangle, right? You got these 2 angles that are the same. So that means that this side here is congruent to that side there. Sides opposite the angles are the same. No problems. But you're still left with what the heck is that side? I don't have a measure. Well, call it X. We don't know what it is. We need to figure it out, right? If that side is X, the side opposite of B, we also know that the side opposite angle C would be X as well. What we don't know is the hypotenuse. So let's find it. How do I find it? Well, you got the Pythagorean theorem. We know that a squared plus b squared equals c squared. Again, I know these labelings are all wrong technically, and this is A, but you know, A is C. X squared plus x squared, that's 2 of the x squares. That equals c squared. And I want to try to solve this for c, right? That's what I need. So I'm going to take the square root right here, the square root right there. So that's square root of 2, square root of x squared equals square root of c squared. I can simplify a ton of this, right? I mean, square root of x squared, that's just x. Square root of 2 is ugly, so leave it alone. And square root of c squared is c. So I now know a measure for the hypotenuse. The hypotenuse is x radical 2. Woohoo! Well, now, how does that actually help me? How am I going to be able to find the sine, cosine, and tangent? Well, you don't have to have numbers all the time. You can certainly do this with variables. Why don't you take a moment, set up those angles, ratios, I'm going to do the same thing, and then we'll compare answers. Alrighty, hopefully this is what you came up with. When you set up sine, you know, again, it's opposite of hypotenuse, so you've got opposite, which is x. You've got right there, divided by your hypotenuse, which is x times the square root of 2. X divided by x, well, anything divided by itself is just 1, so that's where the 1 came from. And then remember, we have to rationalize. We're not allowed to leave a square root in the denominator, so we end up with square root of 2 over 2 for sine, and then cosine is the same. That shouldn't be a surprise. They're both 45-degree angles, so the ratios for sine and cosine should be equal. Tangent, you end up with, opposite divided by adjacent, which is just 1. And turns out that if you do sine of c, cosine of c, tangent of c, you get the exact same thing. So ultimately right here we're saying that for a, whoops, wrong color, sugar, for a 45-degree angle right here, the sine of the 45 degrees, so instead of b right here, I could have inserted 45 degrees for all of these, because it was sine of b, but we know the measure of b. So the sine of 45 degrees is the square root of 2 over 2. The cosine of 45 degrees is square root of 2 over 2. And the tangent of 45 degrees is 1. This is setting us up for some really great stuff with the unit circle coming up later this week. Okay. Second special, 30, 60, 90. This one isn't going to work out quite as easily as the last one because we're going to need a different triangle here first. So let me go ahead and start out by drawing this. And all I'm doing right now really is recreating what we have below us. Here's our 60-degree angle over here. We have a 30-degree angle at the top. This guy over here is also going to be 60 degrees. This one is 30 degrees. So all together you'll notice that I really have just created an equilateral triangle. All sides here are equal. All angles are 60 degrees. Now why did I do this? Well, let's think about it like this. If I'm going to call this side down here at the bottom x, which means that this little side right here, from here over to there, will be x. What do I know? Well, let's see. That's half of this bottom distance, right? This little x right here is half of the entire bottom distance, which means that this upper part here is twice x. That's 2 x's. Okay, how does that help me? Well, if I know that this hypotenuse here is 2x of my big triangle at the bottom, that would leave this side here as the only unknown side in my special 30, 60, 90 degree triangle. So I can go back over here and use my Pythagorean theorem. X squared plus unknown side, we'll call it b squared, equals quantity 2x squared. X squared plus b squared equals 4x squared. Subtracting x squared on both sides, I get 3x squared. Square rooting to solve, I end up with b equals x radical 3. So to finish up here, to find, let's say, the sine of 30 degrees, I would have sine of 30 degrees equals x over 2x. Divides out, you get 1/2. Cosine of 30 degrees is, let's see, 30 degrees is up here, so I have x square roots of 3 all over 2x. Again, simplifies there. You get square root of 3 over 2. For tangent of 30 degrees, you have x over x radical 3. That divides out. You end up with 1 over the square root of 3, but then remember you have to rationalize. You end up with square root of 3 over 3. Repeating the process with 60 degrees, sine of 60 degrees is equal to x square root of 3 over 2x. Again, they cancel. You get radical 3 over 2. Cosine of 60 degrees is x over 2x, which is 1/2. Tangent of 60 degrees is x radical 3 divided by x, that's gone, which is square root of 3. Okay, we're nearing the end, folks. If you're asked to solve a right triangle, all that means is find all angles and sides. So whatever they don't give you, you've got to find. So if you look at this, they give me 62 degrees. They also give me a 90-degree angle right here. And so common sense tells you add those two up, subtract from 180. What are you left with? 28 degrees. So the measure of angle A is 28 degrees. Outstanding. So we have all three angles. Now we need the sides. We have one of them. We have to find the other two. Use trig. When you're asked to solve, they don't give you any other instructions, so pick something easy. Sure, you could use cotangent for all of these, but why? Stick with sine or cosine. It's what you're more familiar with, and you're less likely to make a mistake. Let's see, I need side A right here, and I also need side C up top. Let's find side A first. Let's use angle A. Why not? So we have sine of 28 degrees equals opposite, which I don't know, divided by the hypotenuse, which, whoopsie, I don't have either. So this is not wrong, it's just something I can't do right now. If I want to use sine to find anything at the moment, I can't use 28 degrees because I'm working with two unknown sides. That won't work. Darn. How about 62, sine of 62 degrees. If I do sine of 62 degrees, I get 25 over C. Haha, I can do this right now. So C equals 25 divided by the sine of 62 degrees. And that is 28.31 when you round. So the measure of the hypotenuse is 28.31. That makes sense because it should be larger than 25. By the way, if my math right here confused you, all I did was really put this over a 1 and like cross multiply. Again, folks, this is pre-cal. If you need help on Algebra 1, stay after. For the last one, I need side A. Well, then now I could go back and finish my sine 28 degrees equals A over C because now I have a value of C. I would not recommend doing that. When you use rounded answers to find more answers, it just causes you to be less and less precise. So that's not ideal. Let's go back and use something else here. We have A that we need. We have this angle. We have this side. Let's just go ahead and do the tangent. We've got tangent of 62 degrees equals 25 over A. Solving again, we have A equals 25 over tangent of 62 degrees. That looks like tan, sorry about that. A is equal to 13.29. And there you have it. At this point, we have found all three angles and all three sides. Last slide, just some quick hints on calculator errors. Biggest one is watching your mode. If you're doing calculations with degrees, make sure you have it in degrees. Radians, of course, you need radians. The next one, these didn't come out quite correctly here. This should actually say tangent of 30 to the negative 1 power. This one should be tangent negative 1 power to 30. There are differences between them. This guy right here is saying that I want the inverse of the tangent of 30 degrees, which is the cotangent. This one is actually asking for you to find the inverse tangent at that angle, so it would return the ratio for tangent of 30 degrees. Just be careful. I advise you to use 1 over tangent of 30 degrees anyway if you want to find the cotangent. You can't type cosine of theta parentheses cubed. You have to be careful. You have to actually type it as cosine cubed theta. It's a little issue with the calculator. We'll worry about that when we get to it. And then, of course, the last one is not closing parentheses when you're doing calculations. All right, guys, thanks for watching. I'll see you in class.